Hi everyone. Today we're going to be looking at the Click PLC EasyPLC Gantry Simulator. Now the Machine Simulator, or MS, is part of the EasyPLC software suite. It has many built-in machines that can be programmed. The Gantry loader is one of these machines. It will pick up metal boxes from a conveyor and place them on a wooden pallet. The Click PLC will be used to program this virtual machine. Now, using the Click PLC, we will be connecting the simulator to the Gantry loader machine. This will be done using Modbus TCP Ethernet for communications. Using the 5 steps for program development, we will show how this is programmed. The logical sequence step will include a flowchart and sequence of operations. The sequence of operations will be done using indirect addressing in the Click PLC. Let's get started. Now, detailed information contained in the video can be found at accautomation.ca. The link has been put in the description below. If you have not watched the other videos yet, there'll be links in the description below that will start you at video 1. There'll be links to the rest of the videos in the series as well. So the first step is defining the task, and this is for our Click Gantry loader. Now the Machine Simulator has a demo mode, and first of all we'll start the Machine Simulator, and you'll see down here is our Gantry loader. Clicking this, we have a demo mode, and a demo mode will allow you to watch the Gantry loader in operation to get you knowledge of exactly what's required with our information. And clicking on this, you will see that you'll also see a description of what has to be done with the Gantry loader. In our case here, it basically says to manage the Gantry to pick the metal boxes from the conveyor belt and place 2 metal boxes on the wooden pallet. And the wooden pallet is located in the roller a conveyor roller. Now when the conveyor belt is on, it will provide boxes. Use the inductive switch to stop the belt in order to pick up the box with the gantry. Manage the conveyors stop to place the wooden pallets in the downward position. The gantry is operated with 6 digital outputs to the left, move left, right, up, down, close, and rotate. 4 inputs are used to inform you of the gantry position: left, right, up, down. And once the box is picked up in the longitudinal sense, it must be placed on the pallet in the transversal sense. So the gantry grips must be rotated during the movement or before to place the pallet. And when the pallet has 2 boxes, it can be released. So that's basically what we have to do here. Next would be next step in, once you fully understand what has to be done or get a sense of what has to be done, then step number 2 on the Click Gantry loader would be to define the inputs and outputs. So the EasyPLC simulator, Machine Simulator, will actually have a start, and what this will do is it will start our Gantry loader, and we can actually view the I/O. So here is our I/O here, and we can actually then determine how many we need for inputs and outputs. And what we can actually also do is to also help us define what has to happen. We can actually move this. So we can rotate the gripper, and we could also turn on lights. So there's several different things that we can do in order to define what has to happen. So again, what you want to do in this step is to define those inputs and outputs and determine exactly what you need. And in our case here, we're going to go into the Click PLC. So once we have defined and we can activate those outputs and determine exactly what we need those outputs to do, then what we can do is take a look at the inputs and outputs from the Click PLC. And if I open up the software for that, here we go. On my Click, here we go. And you will see that if I look at my addresses, we look at the address picker, and on the address picker, what we'll see is we'll look at the X's, and here is a list of my inputs that are coming from the machine simulator. And what we can do is turn on the display of the Modbus, and you can see our Modbus addresses here. We can do the same for our outputs, or to our Y, start at Y101. And again, here is a list of our digital outputs that we are going to use to control how this machine simulator functions. And then we have our analog, and that's under a DS. And DS 101 will be our gantry X set position and our Y set position on DS 102. And then our gantry axis X position coming back and Y position coming back or feeding back into the click will be a DS 111 and DS 112. So that is, and there are corresponding Modbus addresses. So we'll just hit OK. And so that is what the addresses will be. Now, once we have our addresses, then what we do is we look to develop a logical sequence of operation for our gantry loader itself. So if we actually look at the loader, at the sequence of operation, you can see that what we really have is we have a box coming in on one conveyor, we have a gantry, and then we have a pallet. So if we separate this into three different types of program here, we can see that we can do the sequence or logical sequence for a box coming in and stopping. We can then do a logical sequence for our gantry to pick up the box and place it on the pallet twice, because we need two boxes. And we can use a logical sequence for the pallet to come in and stop at the appropriate stop so that it presents itself so that we can load that pallet. And then once the pallet is loaded, it gets released down the conveyor belt. You also notice we have some lights here on the side, and that's what we'll also do. So the first thing we'll take a look at is then our box. And if we produce a box, again, what we can do to get these sequences is use a flow chart. And in the flow chart here, we have our box create, and we basically say, okay, is the machine running? If it is, then is a box present, which is from the sensor. And if it is, then we don't do anything. If it isn't, so our machine's running, yes. Is the box present? No. We run our conveyor, we create our box, and then is machine running? And then we say, yes. Is the box present? Yes. So then we stop that conveyor. So that is basically a simple flow chart that tells us exactly what happens with our box creation. And here is our sensor located right here. So we turn on the conveyor belt, we turn on the box create. As soon as it sees that sensor, it stops. So we can also take a look at the gantry and what has to happen with our gantry. And for this, what we'll use is a sequence of operation. So here is our gantry sequence of operation. And what I've done is take a look at our inputs that are coming in. And we've changed these around a little bit. So we have our green light that indicates that we're good to go. Then we have our grip open, grip close, X movement, Y movement. We have our gantry part detect. We have our box in place, and X is less than 20. We have our pallet in place. We have our gantry stop rotate, gantry above box. Then we have our gantry above the first pallet position and then the second pallet position, just to give us a sequence for that box to be in. And then we set the conditions for each of those locations here. And our input channel will come in at DS201. And here is our hex that represents what those bit statuses will be for that rung. And our step address will start at 500. So the step address will be 500, indicating what step we're on. And it will then compare this, and if it's equal, it will set our output step. And our output step here gives us our output channel itself, which is going to be DS202, again in hex and in integer. Then we have our grip close grip open, our gantry move X and Y, and a pallet full condition. And we also have DS 302 and 303, which indicates exactly what the movement's going to be for the X and Y for that step. So as the input conditions are true, it compares it. If it's equal, it sets the output steps. It continues all the way down, and we just fill up our sequence table as we get the logic. So that is a sequence table. Now, all of this can be downloaded, so you can review this in your own leisure and know exactly how this happens, because you must fully understand exactly what every little bit is doing in the logic of your program so that you can actually program what's happening. So the programmer must know everything about the sequence and operation of the machine before you even start to look at the programming itself. So once and this is where you're going to spend a majority of your time discussing, understanding exactly what has to happen in your sequence. After you've done that, then we can go back and we can say, let's develop the PLC program, which is step 4 of our Click Gantry loader system. So now I have my PLC program, and currently right now I'm online, and the first thing we do is we look at our start stop, and we have a start button and it's not the stop button. We will set our green beacon light on. Then we have our stop button, which then resets that green beacon light. And if the green beacon light is on, we use a 1-second pulse to pulse the yellow beacon light to warn the operators that machine is running. When the beacon light is off, then we turn on our red beacon light and we turn on our start button flashing. So that is our sequence of our lighting and starting and stopping. Then we have our box control. So when we have the machine running and we don't have our induction switch or our switch to tell it that we have a box there, then we turn on our conveyor belt and we have a work part creator box. Then we have our pallet control. So again, we have our green light. So the green light is actually being used in our program to determine whether or not our machine is operating. So if we have our green light, our pallet is not full, then we turn on our stop condition on our conveyor to stop that pallet. And if we have a green light, we don't have our photocell 1 and our pallet is full, then we have a work crate pallet. So that will start our conveyor and give us our pallet coming down. Have our green light, our photocell 3, then we can see then our first scan, our pallet is full. It resets our pallet full. And then we have our green light for the photocell 2, then our pre-stop will come up. So basically, as the pallet comes in, it hits the first stop, the second stop behind it will come up to ensure that we don't have a pallet that runs back into it. Next, what we do is we get into our gantry control. And this is comes back to our sequencer here. So the first thing we do in our sequencer is set up all of our inputs conditions. So you can see here, there's my green light, my grip open, grip closed, just go into the corresponding C bits of our program. And that goes right up. And then we have all of our inputs that go in here. And we copy our C bits, we pack them into DS10 or 201, which is our actual pointer. We go back to our box here, DS201 is where our inputs are. So we can compare all of these inputs with the actual address 201. Then we have an always on here, and we're going to set our outputs. So we're going to compare or copy DS301, which is our output, to our physical outputs. to our pointer value, which is DS202. Then we're going to copy DS202. We're going to do that and break it down, unpack it into bits 200 to 215, which gives us our actual outputs. So this DS301 is actually our pointer for us. So that 200 and all those bits, again, this is where we set the actual outputs themselves. Then what we do is we'll say always on, and then again we use the indirect pointer and we set our gantry X and Y based on the indirect addressing of DS300. Then we increment, so there's our gantry X, and then our gantry Y gets set. Then what we have is, once we are finished with our gantry, so it's at the last step, or we have our first scan, what we do is reset these pointers, and we put 500 back into gantry DS300, and 600 back into DS301, which is the default values where we first start. So that basically is our program. So now, once we have our program, then the last step, or the final step, would be testing the program, which is step 5 of our Click Gantry loader. So let's go back to our machine simulator. Here we go. And what we will do is now select IO driver. We will select Modbus driver. And we will configure our Modbus driver. We are using the TCP IP. Our default port ID is, our IP is 192.168.1.230. It's on port 502, which is the default for Modbus. And then our digital I/O, where we looked at before within our Click program, we have our digital inputs. They start at 8224, which is an offset of 1 from what we looked at in the Click address picker. Then we have our digital outputs. They start at 332. Again, we're using 15 and 15, something more than what the actual program actually uses. For our analog inputs and outputs, we have a starting address of 99, and we have 5 of them, and we have outputs of 109 starting with 5. Again, there's an offset of 1. So we'll just hit OK. So now we have our addresses here, and now we have to assign them, and we can assign them manually, or we can hit driver and we hit automatic assignment. When we hit automatic assignment, you can see it actually puts them straight into order for us here. Then we can hit exit and start driver and exit. Now we can see down here that our driver is connected. We can look at the view IO, and our program is actually running in the Click PLC. And just to verify that, we go back to our Click program. There you go. You can see that we are currently in the run mode. And if we call up our data view, we can actually then look at all of our data. So let's look at PLC. We can then look at the data that comes from there. There's our data view. And there we go. There's our settings. So what you'll see is there's my pallet full. There's my gantry X and Y movement. There's my set position right now. There's my gantry X and Y coming back or feedback. Then we have our pointers, and right now you'll see my gantry input pointer is at 500 and my gantry output pointer is 600. The actual values in those pointers are 258 and 14, and we can follow along with our sequence chart in order to figure out what exactly is happening there. So as I start, what you'll notice is that when we go back to review this, it will actually be running, and we can actually see that information being populated. So what I'll do is just move some things out of the way here, and we will go back to our actual data or our screen here, and let's just hit the start button. So you can move it around, hit the start, and now you can see our pallets coming in, and we will now wait. There it is, our pallet's loaded. Our box is now being loaded. There we go. It picks it up, rotates it, and then puts it onto the pallet. And then we're waiting for another box to come in. And once we have the 2 pallets or 2 boxes on the pallet, that pallet will get released. Again, just following our simple sequence. And you will see that the next pallet comes in, waiting for that information. We can actually see the analog inputs here and analog outputs. Now, with the analog inputs and outputs, the Machine Simulator actually uses real values. So what we've done is change the script for this data and put it onto the simulator here, so that we can actually run it using Modbus. And as always, we can actually change the time speed, so we can speed this up or slow it down. We could actually stop, and we can continue, and you'll notice it continues exactly where it will leave off. So what you want to do is, when you test your program, you want to try all the different scenarios that you can possibly do. We can also then move around this environment and actually see everything in operation as we programmed. Now, if you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us, or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button to get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.